Okay, welcome to a presentation on a new measure of angle which I'm going to introduce to you because this is not what you use at school. In this case, I'm saying from degrees to radian measure of angles. And then the first question you must have, all of you, is what is this thing called a radian? So let's see. Now, I've already said here that angles are about turning. And when you say an angle, basically you are referring to an amount of turning. So let's focus our attention on this arrow here, this red arrow here. And I've got an arm there for it to rotate it. So if we have the arrow lying like this on the horizontal there, we can basically say our direction, our principal direction in this case is what is this one, x-axis. So we can say there, whichever measure of angles we're using there, the angle there is 0. Whether we say 0 degrees or we say 0 radians, whatever radian is, before we know it, it's a 0 angle. Now there's no turning. Are we together? Yes. Okay. So now if I decide to pick this arm here and turn this thing this way, I say to turn this thing this way. If you check that, this is the movement you call anti-clockwise. And from today onwards, we're going to call this positive turning. It's positive turning. And the opposite of it, going this way, is going to be called negative turning. Then, let's turn this thing slightly. We'll turn it this way. We have it this way. Then, the angle is there. That's an angle. You can use any measurement for your angle. In this case, when you use radians, listen to me very, very carefully. When we use radians to measure angles, we are actually using real numbers. We're actually using? Yeah. Then in this class, I'm going to make an agreement with you, a convention. A convention is what used to be called the gentleman's agreement. But that is not politically correct now. It's called gentle people's agreement, not gentlemen, gentle people's agreement. So I'm going to use T there. So I'm going to use T there. And the T there is a measure of an angle, and that T there is a real number. And when I'm measuring angles, real numbers, I'm using radians. I haven't said what is a radian. I'm just explaining. All together? Good. So then, that's the situation there. Is anybody lost there? So you can turn this arm right round, and if I turn it right round up to coming back here, basically I would say I've done 1 revolution. And this is what we used to call at school 360 degrees. I don't know whether I must say this thing. According to my impression, I'm talking about Charles Sipa. My impression is that the 360 degrees came about because at some stage the Greeks believed that a year was about 360 days. And the year making its orbit around the sun, whatever, it's forming a kind of a circle. So to measure an angle, what did they do? They said, okay, 360 degrees in a year. They just divided the circle into 360 parts and called one of them a degree. But that was, according to me, I'm saying that was based on that belief. And the beliefs, okay, beliefs are quite dangerous. And the beliefs are not supposed to be rational. How together? Yeah, that's good. So beliefs can mislead you. That's the thing. And I think that's why this degree thing is not working. That's me. Yeah. Okay. So now let's get to something else which is not based on our beliefs. Let's get to something that will be radians and any other things later. I'm saying any other measure later. So then we can rotate that. In that case, there we would say this angle has been met. And then let's come to answer this question. What is a radian? Now, this line which you've been seeing so far here, this red line here, take it as a kind of a fish line, if you know what is a fish line, or a thread, or anything flexible. This line is actually a copy of this x-axis here. In other words, you can take this as a copy of that x-axis, just copy and paste it and put that thing there. In other words, 0, which was here on the real number line, 0 which was here on the line, on this red line, 0 is here. 0 is here. Do you agree, guys? 0 is there. Then I'm going to count going upwards, and maybe 1 is somewhere there. And here our 1 is here. In other words, the radius of this circle here is 1. The radius of this circle is 1. So that one which is marked here at the circle is on the vertical copy is standing there. But fortunately this line is flexible. What do? I pull it this way. I pull it that way and put it in that position. And you can see that somewhere here it has got a kind of a tangent. That straight line there has got a tangent point there. What do we have then? We have 1 here, and this is another 1 radius here. And actually, as I'm pulling this wire, this flexible line here, what happens here? This point 1 here comes and coincides with that point. In other words, what I'm saying the arc here, this arc here, is actually of length 1. So what do we have here? We've got a kind of an equilateral situation, not equilateral triangle, but an equilateral kind of figure. This is 1, 1, 1. And then this angle which is made here, we call it 1 radian angle. Am I making sense? You will say you've got 1 radian angle when the arc subtended by the angle there, let's call that angle T again. The arc subtended by the angle there on the unit circle is 1 radian. So if this arc is 1 radius length, the radius I said is 1. This arc is 1 radius length, then the angle which is made there is 1 radian. Guys, please, if I'm not making sense, just tell me you're not making sense. And that one is not different from the one which is the real number, because I said this is a copy of a real number. So that is a real number. That is an angle of 1 radian. T is equals to 1 radian. We just write like that. But normally we don't write the units radians like degrees always. We can just say the angle is 1. And as long as you understand that it's radians, we just leave it as like that. Am I making sense, guys? Okay. So if I follow this kind of a pattern, I can turn this thing until it's somewhere there. What am I talking about? I can talk about something like this. So I can come here, turn it and put it there. Before it was here as 1 radian. Turn it around, pulling the thread around and be there. Turn it around and be there. Turn it around until it's back there. Then I've got our 1 revolution. Am I making sense? Now, please interpret this thing this way now. Please put your pen down and listen to me carefully. Interpret this thing this now. When we go to that thing of 1 radian, we said the angle there is 1 radian when this length, this radius here is 1 radian, and that radius here is 1 radian, and this arc here is 1 radian. What I interpret here, and what the interpretation I want you to have, a very practical interpretation I want to have, is that now an angle is being measured using this 1 real number, plus an angle is being measured by the length of the arc. By the length of the arc from this point to that point, the length of the arc is 1. If these numbers were centimeters, we would say that length is 1 centimeter. Yes or no? So message, the angle is measured by the length of the arc it makes. Angle. So the angle is measured by the length of the arc it makes, or we can say it subtends. Subtends. We say this arc here is subtended by that angle. In other words, the angle opens the arc and holds it like this and say the arc is subtended by the angle. Guys, if that does not make sense to you, please tell me that it doesn't make sense. Does it make sense what I'm saying? I'm saying the angle is simply measured by the length of the arc it makes, not by degrees, but by the length of the arc it makes. And the length of the arc is real number. And we're working out together. Okay. Now, let's come back to this simple reasoning. We said to ourselves that as a conference, we taught this thing at school without even understanding a lot of things, what was the real number. We thought that as a conference was always going to be given by the formula pi diameter. In our discussion of real numbers, we arrived at the point that pi was an irrational number. So, in other words, pi cannot be put in this form with q not equal to 0, p and q integers. We arrived at that fact, we discussed that altogether. But at school we told that, no, the circumference is something like this. But remember, the circumference is the arc which is made by the angle of one revolution, total 10. Do you agree? Okay. So then what is this? This, remember, I can also take it as 2 pi r. But now if we've agreed just here that this circle is a unit circle, to mean a circle of radius 1. That's what it means to say unit circle. To mean a circle of radius 1. Now, if this circle is a unit circle, so which means here r is equals to 1, which means then the circumference is what? Is 2 pi. Yes or no? When is the circumference? The circumference starts here and go right round and come back there. But we've just said something here. Angle is measured by the length of the arc it subtends. Then a revolution, total angle 10 of revolution like that, subtends an arc which is the circumference. So what is a revolution in using real numbers? A revolution in real numbers, a revolution in real numbers is equal to an angle of 2 pi. I'm done. From today onwards, when I say what is the size of the revolution? The size of the revolution is the length of the circumference of the circle of 1 unit. So the revolution is of measure 2 pi radians. So we play around with this idea and you fix this circle at radius 1. And you find that the length of the arc around the unit circle is 2 pi. So the angle around the revolution is 2 pi. And now not 2 pi degrees, it's 2 pi radians. And from today onwards, we measure the angles in real numbers. And the unit is radians. We measure distance in real numbers. And the unit is millimeter. We measure time in real numbers. And the unit is second. I'm talking about the SI unit, the standard international units. Am I making sense? We measure mass in real numbers. The unit is milligrams or kilograms, whatever. It's times in SI units. Yeah. Now, before at school, when we turned up to there, we said we're making a straight line. But when we do that, we're making half of the revolution, which means the angle here is what? Is pi. Altogether. So we're actually saying now here, pi is this sign here which I'm using here. I don't want to say equal. I've been using equals for too many years, but it feels very uncomfortable for me to say some division on this circle is equal to a real number. So I'm just going to say use this sign here to mean it is equivalent, like we talk about equivalent fractions and whatever. So an angle of pi radians is equivalent to what? To what? 280 degrees. So what I want to do here with this thing here, we want to get to something I can call conversion formula. I want to use conversion formula or even conversion formula because they're going to be two. I need to move to convert degrees to radians and be able to convert radians to degrees. Altogether. So let's say this thing. Remember now here, these are radians. And here we're having degrees. So now if I wanted to get 1 radian, you want to make 1 radian. 1 radian. I think you are sure that I'm going to divide pi by pi, isn't it? If I divide pi by pi, I get 1, isn't it? Yes or no? If I divide pi by pi, I get 1. Do you agree? Yes. Okay. So now, if I want to run 1 radian, I have to divide this by pi. So, but this is a kind of an equation of some sort. So when I can say 1 radian here is going to be 180 divided by pi. Now, this number here now, this number, I take it as a coefficient which I can use to convert. Now let's say in this case I had 180 degrees equivalent to pi radians, and now I want 1 degree. I want to know what is 1 degree. I will divide both sides here by 180. If I divide this by 180, I'll get 1 degree. Do you agree? So then this side, I'll divide pi by 180. Remember, I divided by 180. I didn't divide by 180 degrees. There's no units in this thing. There's no unit in this thing. So what I'm getting here is actually a radian. Because it's pi radians. So what I'm getting here is in radians. So now, if I've got 90 degrees, I want to convert this to radians. I'll get this thing like this. I will allow you to use equal sign there. You can use equal sign for all practical purposes. You can use equal sign, but I'm using equivalence for the reasons that I want to feel comfortable with my soul. So what happens then? I'm going to take 90 and say every degree is this radian. Every degree is this radian. So I'm going to multiply here and say 90. And then I say what? Pi over 180. If you simplify here, we're going to say 90 here, 1. 90 here, 2. And then 90 degrees is going to be half of pi. So the angle now here, it's not going to be called 90 degrees. It's going to be pi over 2. In other words, halfway to making a straight line. Does that make sense? Yes or no? When I'm here at 90 degrees, it's actually halfway at making a straight line. What is a straight line? 180. 180 equivalent to pi. And actually this half to making that is actually 1/4 of a revolution. That's the thing. So that's the thing. So now, which means now, if I want to convert from degrees to radians, I multiply by this vector. So I'm saying 2 rad converting vector. In other words, to radian, that is to radian converting vector. This is the vector used to convert to radians. All together? Okay. Now what will be this? This will be a vector which you use to convert to degrees. So now let's say you have got half pi. You know where your half pi is halfway to a straight line. You want to know what is this equivalent to in degrees. What did you do? You take your half pi, you multiply by this vector, call this 2 degrees converting vector. You write it down. I'm not going to write it down, don't have space there. 2 degrees converting vector. So you take this number, you write 180 over pi. And then pi over pi is 1. Simplified. 2 here 1. 2 here 90. Then we get here this thing giving us 90 degrees. Homework. The homework. You have a list of angles you call special angles. 0, 30, 45, 60. I'm talking about degrees, isn't it? I think even 180. Go and convert all of them to radians. Convert all of them to radians. When you come here, I want to see the list. All together, guys. Then, at that point, guys, I think the concept of a radian is understood. Are there any questions? I said you take this as homework. I said to take this to homework. Go to your table of special angles in degrees. I think there are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. I think even 180 is one of them. And the pi we know is 2 pi. And sorry, 360 we know is 2 pi already. That's why we started. Even 180 we know already. We're talking about it here. It's 2 pi. So basically, it's these 4 because 90 we've already done it also. Altogether, everybody must do that, guys. I said everybody must do that. Now the question which I've got is the concept of a radian sitting. We are measuring angles using real numbers. The size of an angle is the length of the arc it subtends. Altogether. So at that point, guys, I would like to say thank you for listening. My name is Charles Wells Van Msipa.